Hello classmates, welcome back to today's lesson. So today we're going to be looking at a question from a previous paper, and the scenario of the question goes as follows. The owner of the holiday resort planned to build a cylindrical pool. The pictures below show the existing rectangular swimming pool and a cylindrical swimming pool which the owners plan to build at the holiday resort. And as you can see over there, we have been given the picture of both the cylindrical swimming pool and the rectangular swimming pool, as well as their inner dimensions. And if you furtherly inspect the scenario, we have also been given the dimensions of a single tile, and we have also been told that a single box of tiles will have 16 tiles inside of it. And we've also been told that 1 cubic meter equals to 1000 liters. So we are going to do question 4.2.3, which is worth 8 marks, and the question goes as follows. Calculate, rounded to the nearest liter, the difference in volume of the two swimming pools. You may use the following formula. Calculate, rounded to the nearest liter, the difference in volume of the two swimming pools. You may use the following formula. And we have been given the formula to calculate volume of a cylinder, and also the formula to calculate volume of a rectangular prism. So this obviously means that we need to calculate the volume of the cylindrical swimming pool using the formula given to us, and also calculate the volume of the rectangular swimming pool as well using the formula which has been given to us. And then after that, we're going to take the two volumes and determine the difference between them, which means that we're going to take the bigger one and subtract the smaller one, and then we will get the difference. But the difference is going to be in what? In cubic meters. So we're going to have to take the information given to us there and convert our volume from cubic meters to liters. And before I answer this question, please attempt to answer it first, and then when you're done, you can later come back and watch the video to see if you got it right or you made some mistakes. Okay, so we are going to start by calculating the volume of the cylindrical pool using the formula that we've been given on the question paper. So the formula says that volume of cylinder equals to 3,142, which is pi multiplied by into brackets radius squared multiplied by d for depth. Okay, let me just write it here for depth. So this is the formula that we've been given on the question paper, and it is the formula that we are going to use to find the volume of the cylindrical swimming pool. So now we are going to substitute. So it is going to be 3,142 multiplied by, so when you look at the dimensions, at our dimensions, you will notice that we do not have the radius. Instead, we have the what? The diameter. And remember that when we calculate the radius, we just take the diameter and divide it by 2, and that will give us the what? The radius. So in our brackets, we're going to say the diameter, which is 7 meters, and divide it by 2. That means that the brackets will give us what? The radius. And then we also put the square as well, multiply by the depth. The depth of the pool is only 1 meter. So now we have substituted our formula, right? So let's work with the brackets first before we could do the whole calculations. We're going to say 7 divided by 2. We are now determining the radius. So that means that our radius is at 3.5. So we're going to say 3,142 multiplied by 3.5 squared multiplied by 1 meters. Okay, so now we have simplified our equation, and we can now get the answer. So we're going to hit the whole thing on the calculator. It's 3,142 multiplied by 3.5 squared multiplied by 1, and that gives us a total of 38,4895 meters cubed. So that means that the volume of the cylindrical swimming pool equals to 38,4895 cubic meters. So now we're going to calculate the volume of the rectangular pool. And remember that we've also been given the formula to calculate the volume of the rectangular swimming pool. So the formula says volume equals to so the formula is length multiplied by width multiplied by the depth of the pool. This is the formula that has been given to us, and what we need to do is just to substitute the formula and get the answer. So the length of the pool, looking at the dimensions that have been given to us, the length of the pool is 6.2 meters multiplied by the width of the pool, which is 3.25 meters, and the depth is 1.65 meters. So now we have substituted our formula, and then we can hit the whole thing on the calculator and get the answer. So we're going to say 6.2 multiplied by 3.25 multiplied by 1.65. That gives us a total of 33,2475 cubic meters. So this is the formula of the rectangular pool. So now we have the volumes for the both pools, and what we can do now is that we can calculate the difference. Remember that we've been asked to calculate the difference between the pools in liters, but we're first going to calculate it in meters as it is. So we're going to take the volume of the cylindrical pool and subtract the volume of the rectangular pool. That will give us the difference between the two volumes. So we're going to say, therefore, 38,4895 cubic meters minus 33,2475 cubic meters. And let's see what the difference will be. 38,4895 minus the answer. That gives us 4.242 meters cubed. So this is the difference between the two volumes, between the volume of the cylindrical pool and the volume of the rectangular swimming pool. The difference is 5.242 cubic meters. Now remember that you have been told that your answer should be rounded to the nearest liters. So that means that your final answer should be in liters. And if you see here, our answer is written in what? In cubic meters. So that means that right now we have to take the cubic meters and convert them to liters. And we are going to use the piece of information given to us there at the end of the table. Right there, it's written, note 1 cubic meter equals to 1000 liters. That is the information that we are going to use to find how many liters we have in 5.242 cubic meters. And that means that we're going to do what? Since we have been told that 1 cubic meter equals to 1000 liters, we're just going to take 5.242 cubic meters and multiply it by 1000, and that will tell us the amount of liters that we have in 5.242 cubic meters. So it's 5.242 multiplied by 1000. That gives us 5,242 liters. So that means that the final answer, the difference between the volume of the cylindrical swimming pool and the rectangular swimming pool in liters is 5,242 liters. This is the final answer. And the next question, which is question 4.2.4, the total inner surface of the cylindrical pool will be tiled. An additional 10% tiles were purchased. You may use the following formula, and we have been given the formula to calculate the surface area of an open cylinder. So just to explain what they are saying here, they are telling us that they are going to tile the inner surface or the inside of the cylindrical swimming pool, and on top of the tiles that will be required to tile the inside of the pool, they also purchased an additional 10% of tiles. So The question says that the tiler states that he requires more than 100 boxes of tiles to complete the tiling. Verify showing all calculations whether his statement is valid. The tiler states that he requires more than 100 boxes of tiles to complete the tiling. Verify showing all calculations whether his statement is valid. So what we have to do here is that we need to determine the number of boxes or the amount of boxes of tiles that will be required in order to cover the surface area of the cylindrical swimming pool, including 10% extra of the tiles that were purchased. So this is how we're going to answer the question. So this means that we have to calculate the number of tiles that are going to be needed in order to cover the surface area of the cylindrical swimming pool. So that means that we are going to start by doing what? We are going to start by calculating the surface area of an open cylinder using the formula given to us over there. So the formula says that surface area equals to 3,142, which is pi multiplied by radius multiply by into brackets radius plus 2 multiplied by depth of the pool. So this is the formula that has been given to us on the question paper, and we are going to substitute. So it's 3,142 multiplied by the radius. We do not have the radius, but then remember we calculated it on the previous question and we found out that the radius is 3.5 meters. Multiply by into brackets the radius again 3.5 meters plus 2 multiply by the depth of the pool, which is 1 meters. So now we have substituted the formula and we can make the calculation. So we're just going to click the whole thing on the calculator and say 3,142 multiplied by 3.5 multiply by into brackets 3.5 plus 2 multiply by 1 and close the bracket. That gives us a total of 60.4835 meters squared. So this is the surface area of the cylindrical pool. And now that we have the surface area of the cylindrical pool, we can do what? That means that the next step is to calculate the area of a single tile. We have the area of the swimming pool, and now we need the area of a single tile in order to know how many tiles will be needed to cover the area of the swimming pool. So if you look at the dimensions of the tile given to us there, the dimensions are written in centimeters and our area is in meters. So that means that we have to do what? We have to take the dimensions of the tile and convert them to meters before we can calculate the area, so that the area will be in meters and we'll be able to work with it using the surface area of the swimming pool. So we're going to say 20 centimeters and we're going to convert it to meters. So when we convert from centimeters to meters, we divide by 100. So we're going to say 20 centimeters divide by 100, 20 divide by 100, and that gives us a total of 0.2 meters. So now that we have the dimensions of the tile in meters, we can calculate the area of the tile in meters. Remember that we've been told that a single tile has dimensions of 20 centimeters by 20 centimeters. We converted the 20 centimeter to meters. So that means that the dimensions in meters are 0.2 meters multiplied by 0.2 meters. So now we're calculating the area of a tile. Area of a single tile equals to 0.2 meters multiplied by 0.2 meters. So let's see how much that gives us. 0.2 multiplied by 0.2, that gives us a total of 0.04 meters squared. Remember, it's the area. Area should always be written in squared. So the answer is 0.04 meters squared. So now we have the area of a single tile and we also have the surface area of the swimming pool. We can now determine how many tiles will be needed to cover this surface area. So we are going to take the surface area, which is 60.4835 meters squared, and divide it by the area of a single tile, which is 0.04 meters squared. So this will tell us that how many tiles will get into the surface area of the swimming pool. So we're going to say 60.4835 divided by 0.04, and that gives us 60.4835 divided by 0.042. that gives us a total of 1512.0875 tiles. So this is the number of tiles, and remember that we cannot have number of tiles as a decimal. It needs to be a whole number. So that means that we have to round up. And I also need you to note that every time we talk about tiles, every time you do any calculations regarding tiles, you have to round up, because when it comes to tile, we'd rather have extra tiles than to have a shortage, right? So that means that the number of tiles here will be 1513 tiles. Okay, so this is the number of tiles that are going to be needed to cover the area of the swimming pool, to cover the surface area of the swimming pool. And remember that they also said that an additional 10% tiles were purchased. Additional 10% tiles. So that means that we still need to add 10% of these tiles. We still need to add 10%. So we're going to say 1513 plus, and then into brackets we're going to calculate 10% of 1513. We're going to say 1513 multiplied by 10 over 100. So in the brackets we will get 10% of this number and add it together with the number of tiles. So we are going to say 1513 multiplied by 10 over 100. 10 over 100, and that, okay, so it's 1513 plus 10%, which is 151.3. We're going to add these two together, 1513, and it gives us a total of 1664.3 tiles, which means it's going to be 1665 tiles. We round up because we are talking about tiles. Always when we talk about tiles, we round up. Okay, so that means that 1665 tiles were purchased or have to be purchased. Okay, so now that we know the number of tiles, we need to determine the number of boxes that these tiles will fit into, right? So going back to the scenario, we have been told that one box carries 16 tiles. There's going to be 16 tiles in a single box. Okay, so we're going to take the number of tiles and divide it by 16, and that will tell us that how many boxes will come out of the number of tiles that we have. So we're going to say 1665 divided by 16, and that gives us 104,0625 boxes. So just like boxes, just like tiles, we cannot have the number of boxes as a decimal. It has to be a whole number. So that means that 105 boxes of tiles will be needed. And remember that the question was saying that the tiler states that he requires more than 100 boxes, and the calculation does confirm that he is going to need more than 100 boxes. So that means that the statement is valid. So you're going to write the conclusion as well and say that statement is valid. So the tiler is telling the truth when he says that he is going to need more than 100 boxes of tiles. So this is how you guys were supposed to work with the question, and I hope that I have explained it better in a way that you guys understand it now. And I hope that there is no confusion here in terms of these two questions, and I hope that you guys understood.